All right. Today we're diving into DeepSeek v3. This new open source language model is really something else.
It really is quite remarkable, especially when you consider the sheer scale of it.
Oh yeah. We're talking 671 billion parameters.
It's just mind-boggling, isn't it?
It really is. And yet it manages to be incredibly efficient.
That's one of the things that makes this paper so fascinating. They've achieved this incredible scale without compromising on performance or efficiency.
So how do they do it? What's the secret sauce behind DeepSeek v3's efficiency?
Well, there are several key factors at play here, but one of the most prominent is their mixture of experts approach.
Mixture of experts. That sounds intriguing. Can you break that down for us a bit?
Sure. So imagine you have a team of experts, each specializing in a particular domain.
Okay, I'm following you.
Now, instead of having one model that tries to handle every single task, DeepSeek v3 has this collection of experts.
Right, so it's like dividing and conquering.
Exactly. Each expert is responsible for a specific area of expertise, and for any given input, only the most relevant experts are activated.
So it's not just one giant model trying to be a jack of all trades. It's more like assembling the perfect team for each specific task.
Precisely. And this approach has several advantages.
I bet it does. Like what?
Well, for one, it reduces the computational burden significantly. You're not activating all 671 billion parameters for every single input, only the ones that are actually needed.
That makes sense. So it's more targeted, more efficient.
Exactly. And it also allows for greater specialization within the model. Each expert can focus on its specific domain and become really good at it.
So it's like having a team of specialists instead of one general practitioner.
That's a great analogy.
Now, how does DeepSeek v3 determine which experts to activate for a given input? Seems like that would be a complex decision-making process.
It is, and this is where the DeepSeek Mo architecture comes into play. It analyzes each incoming token, and based on its content, it routes it to the most relevant experts.
So it's like a dynamic routing system.
Exactly.
It's analyzing the information and directing it to the right destination.
Now, the model actually calculates what the researchers call token-to-expert affinity, which essentially quantifies how relevant each expert is to the given token.
So it's like a matchmaking system for tokens and experts.
You could say that. And based on this affinity score, the model selects the top K experts for processing that specific token.
Top K.
Yeah, so they don't just activate one expert, they activate a small subset of the most relevant ones.
Okay, that makes sense. So it's like getting a second opinion or even a third opinion just to be sure.
It's more like getting the most qualified opinions for that particular piece of information.
Now, routing efficiently in a model of this scale must be quite a challenge.
Oh, absolutely. And the researchers had to come up with some innovative solutions to address this.
Like what? What kind of tricks did they pull out of their sleeves?
Well, one of the most notable innovations is their auxiliary loss-free load balancing strategy.
Auxiliary loss-free. That's a mouthful. Can you unpack that for us?
Sure. So traditionally, MOE models use an auxiliary loss function to ensure that the workload is distributed evenly among the experts.
Okay, I'm following you.
But the authors found that this traditional approach could sometimes negatively impact the model's overall performance.
Interesting. So it's like trying to micromanage the experts too much.
In a way, yeah. So they devised this method to achieve balanced expert loads without relying on these potentially detrimental auxiliary losses.
Okay, so how does that work? How do they achieve that balance without the micromanagement?
Well, they introduce a dynamic bias term for each expert, and this bias term is adjusted during training.
So it's like giving each expert a little bit of weight.
You could think of it that way. And if an expert is becoming overloaded, its bias term is decreased, making it less likely to be selected for subsequent tasks.
So it's like saying, hey, you're getting a little overwhelmed, take a break.
Exactly. And conversely, if an expert is underutilized, its bias term is increased.
All right, you ready for more action? Step right up.
Precisely. So it's a self-regulating system that prevents any expert from getting overwhelmed or left idle.
It's all about finding that perfect balance.
Exactly.
So they didn't stop there, did they?
Oh, no, they didn't. They also introduced something called multi-token prediction, or MTP.
MTP, another acronym. I'm intrigued. Tell me more.
Well, this is where things get even more interesting. Instead of predicting just the next token in a sequence, DeepSeek v3 attempts to predict multiple future tokens simultaneously.
Whoa, hold on. It's like the model is trying to see into the future.
In a way, yes. It's trying to anticipate what's coming next, not just react to what it has already seen.
That's incredible. How does that even work?
Well, the implementation is quite complex, but essentially they maintain a complete causal chain for each prediction depth.
That's causal chain.
Yeah, so each prediction is informed by the predictions that came before it.
So it's not just making isolated guesses about future tokens. It's building a coherent understanding of the entire sequence.
Exactly, and the authors suggest that this multi-token prediction capability might enable the model to pre-plan its representations.
Pre-plan.
Yeah, so by considering multiple future tokens, it can potentially create more robust and meaningful internal representations of the input.
So it's not just about predicting the next word in a sentence. It's
Yeah.
more about grasping the overall direction of a conversation or the logical flow of a code snippet.
Precisely.
Now, this MTP thing, it sounds incredibly powerful, but I imagine it must be quite computationally expensive as well.
You're right, it does add some computational overhead, but the authors have found ways to mitigate that.
Okay, like what?
Well, one way is through speculative decoding, which essentially allows the model to make educated guesses about the most likely future tokens and generate those tokens in advance.
So it's like pre-computing those tokens.
Exactly. And if those guesses prove correct, it saves a significant amount of time.
So it's a gamble, but a calculated one.
Precisely. And the authors have shown that this speculative decoding approach can lead to significant speedups in inference.
That's amazing. So we've got this incredible mixture of experts approach for efficient routing. We've got multi-token prediction for anticipating the future. It's like DeepSeek v3 is a time traveler.
Well, it's certainly pushing the boundaries of what's possible with language models.
It really is. Now, all of this complexity, this sophistication, it must require some serious computational muscle to train.
You're absolutely right. DeepSeek v3 was trained on a cluster of 2048 NVIDIA H800 GPUs.
2048 GPUs. That's insane.
It's a massive amount of computational power.
It really highlights the scale we're dealing with here.
And even with all that power training, took a considerable amount of time and resources.
So they needed every one of those GPUs to make this happen?
Absolutely. And they developed a special training pipeline called dual pipe to maximize efficiency.
Dual pipe.
Yeah. It's essentially two pipelines working in tandem.
Okay. I'm intrigued. Tell me more.
So the primary pipeline handles the heavy lifting of model training, while a secondary smaller pipeline focuses on prefetching data.
So it's like having a dedicated team preparing the ingredients while the master chef focuses on cooking.
That's a great analogy. And this preemptive data handling saves a lot of time.
It makes sense. Keep the data flowing smoothly so the training process doesn't get bogged down.
Exactly. And they've even got a helpful diagram in Figure 4 of the paper that visualizes how this all works.
I have to check that out. All of this is impressive, but I understand they also did something groundbreaking with FP8 mixed precision training. And this is a first for a model of this scale, right?
That's right. It's the first time a model this large has successfully utilized FP8 training.
Now, for those of us who aren't hardware experts, can you give us a quick rundown of what FP8 is and why it's such a big deal?
Sure. FP8 stands for 8-bit floating point. It's a numerical format that uses fewer bits to represent numbers compared to the more common FP16 or FP32 formats.
Okay. Fewer bits. So what does that mean in practical terms?
Well, it means less data to process, which translates to faster computation speeds and reduced memory requirements.
So it's like compressing the information more tightly.
You could think of it that way.
But I imagine there must be some trade-offs. Using a lower precision format like FP8 could potentially lead to a loss of precision, couldn't it?
That's a valid concern. And it's one of the main challenges of using FP8 training. You're essentially trying to pack more information into a smaller space, which can lead to errors if not done carefully.
So how did they manage to pull it off? How do they overcome those challenges and make FP8 training work for a model as massive as DeepSeek v3?
Well, they had to develop some very clever techniques. One of them is called fine-grained quantization.
Fine-grained quantization.
Yeah, it's a way of dividing the data into smaller groups and applying specific scaling factors to each group.
So instead of using a one-size-fits-all approach to quantization, they're customizing it to the unique characteristics of each chunk of data.
Exactly. And this helps to minimize errors arising from outlier values.
Outlier values.
Yeah, those data points that are way off from the average. They can cause problems if you're not careful.
Okay, so it's like having a more nuanced approach to compression. And they also address the issue of limited accumulation precision in FP8 GMMs.
GMMs?
Yeah, those are the matrix multiplication operations at the heart of deep learning.
Ah, right. Yes, they had to find ways to increase the precision of those calculations to ensure the accuracy of the final results.
It's like having a built-in safety net to catch any potential precision loss.
Yeah, that's a good way to put it.
So they've got this fine-grained quantization. They've got ways to boost the precision of those critical calculations. It sounds like they've really thought of everything.
They've done a remarkable job of mitigating the potential downsides of FP8 training.
Now, on top of all that, they also implemented some impressive memory optimization techniques, just to make sure the training process didn't run out of steam.
That's right. They had to be very strategic about how they used memory.
So what did they do? Give us the highlights.
Well, one technique they used was recomputing certain operations during backpropagation.
Backpropagation?
Yeah, that's the process of calculating the gradients.
What is?
Oh, sorry. The gradients are essentially the directions in which the model needs to adjust its parameters to improve its performance.
Okay, I'm vaguely familiar with that concept.
So instead of storing the intermediate results of these calculations, they just recompute them when needed.
So it's like clearing the scratch paper after you've solved a math problem.
Exactly. It frees up valuable memory resources.
Make sense? What else?
They also made the strategic decision to store the EMA parameters in CPU memory.
EMA parameters. Remind me what those are again.
Oh, those are mainly used for early performance estimation. And by moving them to the CPU, they free up even more space on the GPUs.
So it's all about making the most of the available resources.
Precisely.
It's clear that a tremendous amount of effort and ingenuity went into making FP8 training a reality for a model as large as DeepSeek v3.
It's a testament to their dedication to pushing the boundaries of efficiency in AI.
It really is. Now, I know we've been diving deep into the technical details here, but ultimately what matters is how well this model actually performs.
That's right. And that's what we'll be exploring in the next part of our deep dive.
I'm excited to hear about it. So stay tuned, folks. We'll be back soon to explore the impressive capabilities of DeepSeek v3 and how it stacks up against the competition.
It's going to be fascinating.
Yeah.
So are you ready to see how this model performs in the real world?
Absolutely. I'm eager to see if it lives up to all the hype. Did they stick to the standard benchmarks, or did they venture into some uncharted territory as well?
They covered a wide range of benchmarks, actually. Everything from well-established ones like MMLU for multitask language understanding to more specialized tests like HelloSwag for common sense reasoning.
HelloSwag.
Yeah, it's a pretty challenging benchmark. It tests the model's ability to make sense of everyday situations and predict what's likely to happen next.
So it's like a common sense test for AI.
You could say that.
I like it. What other benchmarks did they use?
Well, they also tested it on human eval for code generation and GSM-8K for mathematical problem solving.
So they really put it through its paces, through the whole AI benchmark suite app.
They didn't hold back.
How did DeepSeek v3 fare against all these challenges?
It proved itself to be a top contender across the board, especially in code and math-related tasks.
Really?
It consistently outperformed other open source models, even those with significantly more parameters.
So size isn't everything.
Apparently not. And what's even more impressive is that it achieved comparable or even superior performance to some leading closed source models on certain benchmarks.
Wow, that's a remarkable feat for an open source model.
It really is.
It's not just efficient, it's incredibly capable as well.
Exactly.
Now, the paper also highlights DeepSeek v3's ability to handle long contexts.
Yes, that's another area where it excels.
Can you remind me what long context means in the world of language models?
Sure. Long context refers to a model's capacity to process and understand extended input sequences.
Okay, so instead of just looking at a few sentences or a paragraph, it can handle much larger chunks of information.
Exactly. Think of it as the ability to read an entire chapter of a book or analyze a large, complex code base.
Without losing track of the information flow.
Precisely.
Now many language models struggle with long contexts.
They do. As the input length increases, their performance tends to degrade.
So it's like they have a limited attention span.
You could say that.
The DeepSeek v3 seems to be different.
It is. It was specifically designed to excel in this area.
How do they achieve that?
They used a technique known as yarn, which effectively extends the model's context window without incurring a significant increase in computational costs.
So it's like giving the model a boost in its working memory.
You could think of it that way. And this allows DeepSeek v3 to handle input sequences of up to 128,000 tokens.
128,000 tokens. That's like feeding an entire novel into the model.
It is. And it can still make sense of it all.
That's incredible. Did they conduct any specific tests to evaluate its long context robustness?
They did. They designed a clever test called needle in a haystack.
Needle in a haystack.
Yeah, it's a very fitting name. The test challenges the model to find and extract relevant information from extremely long input sequences.
So it's like searching for a needle in a haystack of text.
Precisely.
And how did DeepSeek v3 perform on this test?
It passed with flying colors. It demonstrated consistent performance across various context lengths.
That's impressive. It sounds like they've really made some significant strides in long context understanding with this model.
They certainly have.
Now we know the pre-training is just the foundation. What steps did they take to further refine DeepSeek v3's abilities?
After pre-training, they focused on two key techniques: supervised fine-tuning and reinforcement learning.
Ah, yes, the dynamic duo of AI training.
These are essential steps in honing the model's abilities and shaping its behavior for specific tasks.
Can you give us a quick refresher on what those techniques entail?
Sure. Supervised fine-tuning involves training the model on a more focused dataset, typically consisting of labeled examples that clearly demonstrate the desired behavior.
So it's like giving the model specialized training after it has completed its general education.
Exactly. It's about refining existing knowledge and honing those specialized skills.
Okay, and what about reinforcement learning?
Reinforcement learning is more about guiding the model through trial and error. It involves rewarding the model for producing desired outputs and penalizing it for undesirable ones.
So it's like training a pet with treats and scolding.
You could say that, but instead of treats and scolding, we use numerical rewards and penalties.
Right, of course. So it's about shaping new behaviors and encouraging the model to explore different approaches to problem solving.
Precisely.
And the DeepSeek v3 team implemented both of these techniques with impressive ingenuity.
They did. For supervised fine-tuning, they curated a massive dataset of 1.5 million instances spanning multiple domains.
1.5 million instances. That's a lot of data.
It is. And they used a clever combination of internal models and human annotators to create this high-quality training data.
So they're not just training a model in isolation. They're building an entire ecosystem of AI models that learn from and support each other.
That's a great way to put it.
It's a collaborative learning environment. Now let's talk about the reinforcement learning aspect. How do they go about training DeepSeek v3 using this technique?
They utilized a combination of rule-based and model-based reward systems.
Okay, can you elaborate on that?
Sure. For tasks with verifiable answers like math problems or coding challenges, they used a rule-based system. This system could objectively assess the correctness of the model's output.
So it's like a strict grader who only accepts the right answer.
You could say that.
But for more subjective tasks like creative writing, they needed a different approach, right?
Right. For those tasks, they relied on a reward model. This model could evaluate the quality and relevance of the generated text.
So it's like having a more nuanced critic who can appreciate the finer points of writing.
Exactly. And they also incorporated a clever algorithm called Group Relative Policy Optimization, or GRPO.
GRPO.
Yeah, it's a way to efficiently update the model's policy based on the rewards it receives during training.
Okay, I'm not going to pretend I understand all the technical details there. But the key takeaway is that they've implemented a sophisticated and efficient approach to reinforcement learning.
That's right.
And the results speak for themselves.
They do. DeepSeek v3 has achieved remarkable performance across a wide range of challenging tasks.
Now, I'm particularly curious about how DeepSeek v3 performs as a chat model.
Ah, yes. That's one of the most popular and engaging applications of large language models these days.
Did they evaluate its conversational abilities?
They did, and the results are quite impressive.
Do tell.
They tested it on a variety of standard benchmarks specifically designed to assess conversational capabilities. And DeepSeek v3 consistently outperformed other open-source models.
So it can hold its own in a conversation.
It can. In fact, it even achieved performance comparable to leading closed-source models like GPT-4o and Claude 3.5 Sonnet.
Wow, that's a major accomplishment.
It is. It's a testament to the effectiveness of their training methods and the overall robustness of the model.
Now, they didn't just rely on those standard benchmarks, did they?
No, they also wanted to see how DeepSeek v3 would perform in more free-form conversational settings.
Okay, so what did they do?
They used evaluations like ArenaHard and AlpacaVial 2.0.
ArenaHard.
Yeah, it's an evaluation that utilizes other language models as judges.
So it's like having a panel of AI experts critique DeepSeek v3's conversational skills.
You could say that.
I like it. And how did DeepSeek v3 fare in these open-ended evaluations?
It did exceptionally well. On ArenaHard, it achieved an unprecedented 85% win rate for an open-source model.
85%.
Yes, it consistently outperformed other models in pairwise comparisons.
That's incredible. It sounds like DeepSeek v3 earned a standing ovation from the AI judges.
It did.
And what about AlpacaVial 2.0?
It excelled there as well. AlpacaVial 2.0 focuses more on writing tasks and simple question-answering scenarios, and DeepSeek v3 handled those with ease.
So it's not just a master conversationalist, it's also a skilled writer and a quick thinker.
Precisely. It's a versatile language model capable of handling a wide range of tasks.
Now, before we move on, I want to circle back to the topic of knowledge distillation.
Ah, yes, the transfer of knowledge from teacher to student.
The paper goes into more detail about how knowledge was transferred from DeepSeek R1, the specialized reasoning model, into DeepSeek V3.
Right. They used DeepSeek R1 as a teacher to guide DeepSeek V3's learning process.
So it's like DeepSeek V3 had a private tutor.
In a way, yes.
And did this knowledge transfer lead to noticeable improvements in DeepSeek V3's reasoning abilities?
It did. They observed significant improvements on benchmarks like Live Code Bench and Math 500.
Those are tough benchmarks.
They are. And DeepSeek V3's performance on them clearly shows the benefits of knowledge distillation.
So it's like DeepSeek V3 inherited some of its teacher's brilliance.
You could say that.
But I imagine that knowledge distillation isn't always a smooth and straightforward process.
You're right. It can be tricky.
Did they encounter any challenges?
They did. One interesting observation they made was that while knowledge distillation led to improved performance on reasoning tasks, it also tended to increase the average length of DeepSeek V3's responses.
So it became more verbose, more talkative?
In a way, yes.
Did they have any insights into why that happened?
They believe it's because chain-of-thought reasoning often involves explaining the steps taken to arrive at a conclusion.
Ah, so it's like DeepSeek V3 started thinking out loud.
Exactly, and that led to more detailed but also longer responses.
Interesting. So they had to strike a balance between the benefits of enhanced reasoning ability and the potential drawbacks of increased response length.
That's right.
It's a classic trade-off in language modeling. Now, before we wrap up this part of our deep dive, I want to touch upon one final technical detail that caught my attention: the real-world impact of multi-token prediction on decoding speed.
Ah, yes, MTP in action.
Can you remind me what decoding is again?
Decoding is the process of translating the model's internal representations into human-readable language.
Okay, so it's the bridge between the model's thoughts and our understanding.
Precisely.
And the faster this decoding process can happen, the better.
Right, absolutely. Especially for real-time applications where responsiveness is key.
So how does multi-token prediction contribute to accelerating this decoding process?
Well, by predicting multiple tokens in advance, the model can get a head start on generating the output.
So it's like anticipating the next few words or phrases and having them ready to go.
Exactly.
That makes sense. And did they quantify the speed up achieved through this approach?
They did. They found that combining multi-token prediction with speculative decoding led to a remarkable 1.8x improvement in TPS.
TPS.
Tokens per second.
Ah, okay. So it can generate text almost twice as fast as models that rely on traditional decoding methods.
That's right. It's a significant speed boost.
It sounds like multi-token prediction is a real game changer.
It is. It makes language models more responsive, more efficient, and more practical for real-world applications.
It's clear that the DeepSeek V3 team has done an incredible job.
They have. They've pushed the boundaries of what's possible with language modeling.
And they've done it all in the spirit of open source collaboration.
That's right. They've shared their knowledge, their code, and their insights with the world.
It's inspiring to see such a commitment to open science.
It is. And it's exciting to think about the possibilities that DeepSeek V3 has unlocked for researchers, developers, and society as a whole.
Now, I know we've covered a lot of ground already.
We have.
But there's one more aspect of DeepSeek V3 that I'm particularly curious about. The paper mentions its ability to act as a reward model itself.
Oh, yes. That's another fascinating facet of this model.
Can you tell me more about that?
Sure. DeepSeek V3 can actually be used to evaluate the quality of outputs generated by other language models.
So it's like a language model that can judge other language models.
You could say that.
That's pretty meta.
It is.
And how well does it perform in this role?
They tested it on Reward Bench, a benchmark specifically designed to assess the performance of reward models. And DeepSeek V3 achieved results comparable to GPT-4o and Claude 3.5.
Wow, those are considered to be top-tier reward models.
They are, and DeepSeek V3 is right up there with them.
That's incredible. So it's not just a language model, it's a meta-language model.
Precisely.
It can generate text-engaging conversations and even evaluate the performance of other language models.
It's a versatile and powerful tool.
Now, this ability to act as a reward model opens up some interesting possibilities, doesn't it?
It does. It could potentially learn from its own assessments, continually refining its abilities without relying solely on external feedback.
So it's like having a built-in quality control system.
Exactly.
It's a glimpse into the potential of future AI systems.
Systems that are more autonomous, more self-improving.
This is really fascinating stuff.
It is. DeepSeek V3 is a remarkable achievement.
And it's just the beginning.
I think we're only scratching the surface of what's possible with open source AI.
I agree. It's an exciting time to be following this field.
It is. And I can't wait to see what the future holds.
So where do we go from here? What's next for DeepSeek V3 and open source AI?
That's the big question, isn't it?
It really is. This model has set a new standard for open source AI.
It's raised the bar significantly.
And I think it's going to inspire a whole new wave of innovation.
I agree. We might see models that are not only bigger and better, but also more accessible and customizable.
That accessibility is crucial.
It is. It democratizes AI, allowing individuals and smaller organizations to harness its power.
Without needing the resources of a tech giant.
Exactly.
It levels the playing field.
And it fosters innovation in unexpected corners of the world.
Imagine researchers in developing countries using DeepSeek V3 to analyze local challenges.
Or startups building innovative products and services.
Without the barrier of expensive proprietary AI.
The possibilities are endless.
The paper does acknowledge some limitations of DeepSeek V3.
It does.
Particularly regarding its deployment. They mention that the recommended deployment unit is quite large.
Which could pose a challenge for smaller teams.
Yeah, not everyone has access to a cluster of 48 GPUs.
That's true. But I'm optimistic that these limitations will become less significant over time.
As hardware technology continues to advance.
Exactly. GPUs are becoming more powerful and efficient.
And we can expect these large language models to become more manageable to deploy.
Perhaps even on personal devices or local servers.
That would be a game changer.
It would. It would open up a whole new world of possibilities.
And the research team is already exploring new techniques for optimizing DeepSeek V3's deployment.
They are. We might see breakthroughs in model compression or distributed computing strategies.
That make it more accessible to a wider range of users.
Exactly.
One thing that really struck me throughout our deep dive is the sheer ingenuity and dedication of the DeepSeek V3 team.
They've done an incredible job.
They've really pushed the boundaries of what's possible in open source AI.
They haven't just created a powerful language model, they've shared their knowledge, their code, and their vision with the world.
That's the beauty of the open source community.
It is. It's a collaborative ecosystem where everyone benefits from shared knowledge and collective progress.
And it's exciting to think about the possibilities that DeepSeek V3 has unlocked.
For researchers, developers, and society as a whole.
So as we wrap up this deep dive, what's the one key takeaway you hope our listeners will remember about DeepSeek V3?
I think the key takeaway is this. DeepSeek V3 is a testament to the fact that innovation can thrive in the open.
It challenges the notion that cutting-edge AI requires massive corporate resources.
It shows that with collaboration, ingenuity, and a commitment to sharing knowledge, we can achieve groundbreaking results that benefit everyone.
Beautifully said. It's a powerful reminder that the future of AI is not predetermined. It's being shaped by the collective efforts of talented individuals from all over the world.
Working together to create a future where AI is accessible, beneficial, and empowering for all.
Thank you so much for sharing your expertise and insights today.
It's been my pleasure.
It's been an enlightening journey into the world of DeepSeek V3 and a glimpse into the transformative potential of open source AI.
It's an exciting time to be involved in this field.
It really is. And to our listeners out there, thank you for joining us on this deep dive. We hope you found it informative and inspiring. And until next time, keep exploring, keep innovating, and keep pushing the boundaries of what's possible.
Goodbye.
Goodbye, everyone.